Hey party people, we're going to talk about solving some systems of equations. It's pretty vast. I'm going to... Oh, it's cold. Oh, oh dear. All right, we are going to solve some systems of nonlinear inequalities. We're going to need to find some parabolas. Oh, there's one. Or we could draw our own. Outside is a good place to do it. Get some chalk, draw a parabola, and we're going to think about lines going through them. I prefer the beach for this. It offers a little more sandiness, and there's a good one. But you know what? Let's get one with axes. Here we go. So we're going to try and find where these points of intersection are. There's two in this one. And we're going to have to look out. There are some animals. Oh, hi, doggy. And so let's get to it. So one of the... so that's why we don't do math on the beach. Let's go inside to a whiteboard. All right, so I'm going to find the graph of the parabola first by finding the line of symmetry by using negative b over 2a. And I end up getting 1. And if I plug that back in, I'm going to get out negative 3. And that's the vertex. I can also find the y-intercept. It's always the last number there, and I can reflect a point. You might want to revisit that concept. We're also going to graph the line, and we'll use y equals mx plus b. We know that one. So that's down 2 over 1, starting at negative 1 on the y-axis. And what's really nice here is that it goes straight through some really nice easy points. So we just look at the points of intersection, and those are our solutions. Here I have 0, negative 1, and 1, negative 3. Those are the points of intersection. What we should expect is that we're going to get 2 a lot of the times, but it's possible to get 1 solution, and it's also possible for never to cross ever at all. So let's look at how we can do this mathematically without having to graph it, because that could be pretty difficult. We're going to use substitution by solving one of the equations for y, and we're going to plug it into the other. Once we've done that, we can combine like terms and get it down to a quadratic still. That will need to be solved by a various different amount of methods. So at this point, I have a quadratic here, and I'm going to start solving it, but I have all these different options I could be doing. Factoring, quadratic formula, complete the square. So I'm going to use my best judgment of which one to do. And so let's do the complete the square, which is actually already completed for us. It seemed pretty easy, so I'm going to zoom in, and I get 2 solutions for x. Now, both of those solutions, I'm going to have to plug back into either of the equations. I'm going to pick the easier one, and that's going to give me my y coordinate. Remember we said that we could get not just 2 solutions, but 2 coordinates as our solutions. So when we substitute them back in, we get these 2 values here, negative 3, 7, and 1, 3. All right, this one looks a little wilder. I got this binomial that's being squared. I want to be really careful. There's a common mistake people make, and it's just squaring each part of it. That's not going to work. We have to look at how to expand it. So once I do that properly, I can simplify it by distributing that negative, and I'm still just trying to get it down to something equal to y. So now I can set them equal to each other. Since both of them were equal to y, we could substitute one into the other. At this point, I'm going to move everything to one side so that it's equal to 0. Okay, so I'm choosing my methods. I'm thinking for a second, and you know what? I think this is factorable. You can see here I even thought about it for a second, like, what are the factors? And here we go. 2 x solutions, but remember, we want 2 coordinates. So we're going to take that 6 and that 2 and plug them into whichever equation seems easiest. In this case, I have plugged them into the bottom equation. And I got some pretty wild numbers, but those are in fact correct. So there you go. Systems of equations. You're going to want to substitute in one equation for the other if doing it algebraically. And you might end up using quadratic formula, factoring, complete the square, whichever seems to be the easiest method for you.